Welcome to ETE MCQs. Now let us solve some simple problems in K-map in digital circuits. The first one is the Boolean function f of a comma b comma c is equal to summation 3, 4, 6 and 7 is equivalent to. So we are supposed to find the Boolean function of the given sum of products. The question is given in SOP form, sum of products form. Okay, so the Boolean function f of a comma b comma c is equal to summation 3, 4, 6 and 7. It is given in SOP form. K-map based minimization of the given function. We know that the number of variables is 3. Since the number of variables n is equal to 3, the number of cells in a K-map should be 2 power 3. 2 power 3. So you will have 8 cells in the K-map. So let us construct a K-map with 8 cells A, B and C. 0, 1, 0, 0, 0, 1, 1, 1 and 1, 0. Now you can notice 3 in decimal is nothing but 0, 0, 1 in binary. So you will have, there is 0, 1 to be precise, because it is a 3 variable K-map. So it is 0, 1. So you have a 1 here. For 4 it is 1, 0. For 6 it is 1, 0. And for 7 it is 1, 1. So this is what we have. Now let us perform the grouping. When you perform the grouping, you just look for the one which has got only one possible way to group. In that case, you can notice that this one can, the one, and that is the one which corresponds to 4, can be grouped only along with this one, can be grouped along with this one. Is that okay? And the other possible grouping is only these two. You just have only these two. Whereas we are given with, it is just the equivalent. It is not the minimized version. It is the minimized Boolean expression. It is just the equivalent representation. So let us just complete it. What do we get? The minimized Boolean expression we get is f is equal to, for this case I have a is constant throughout and c is 0. So you have a c bar plus, and this grouping is fine. So you will have plus bc. Now this is your minimized Boolean expression. But the question is very clear. They haven't asked for the minimized Boolean expression. They have just asked for a equivalent. The function is equivalent to. Only that is asked for us. So whether AB is valid, A into B. Yeah, A into B includes this term. This grouping is done. It is actually a redundant grouping. You can just notice this is a redundant grouping which is not preferred in minimized Boolean expression. But if you consider this grouping, you can just get the equivalent function. It is not the minimized function. Again, I repeat, it is, I'll just perform the grouping using red color because it is not advisable when you go for a minimized Boolean expression. So this grouping is basically will get you the equivalent plus, along with this term you can have a plus a b. This is just an equivalent, these three terms together, but actually this is your minimized Boolean expression. And the equivalent representation can be f is equal to ac bar plus bc plus ab. These two are equivalent. Both will realize the same functionality, but this one requires 3 2-input AND gates and 1 3-input OR gate, whereas this one requires 2 2-input AND gate and 1 2-input OR gate. That is enough. So this is a minimized Boolean expression, but this is an equivalent expression. So the question that is asked for us is an equivalent expression. So the equivalent expression is C. C is your equivalent expression. And this is your minimized Boolean expression. But when you want to realize a minimized digital circuit, this kind of grouping is not permitted because this one is already grouped and this one is also already grouped. So there is no point in performing this redundant grouping. This redundant grouping is not preferred. This is a redundant grouping. Redundant grouping is not preferred. Now let us go ahead with the second problem. We are supposed to find the essential prime implicant. So it is very obvious is that we need to make use of K-map. So once we make use of K-map, again it is a three variable function. We will have a K-map with 8 cells. So let me just construct a K-map with 8 cells. And all that you get in the answer will be your all the product terms you have in your solution will be your essential prime implicant. So you have a 8 cell K-map. 1 is equivalent to 001 in binary and 3 is 011. 4 is 100 in binary. 5 is 101 and 6 is 110. Now we are supposed to perform the grouping. Now again you look for the one which has got only one possible way to group. So you just take this grouping. This is mandatory. This one has to be grouped along with this because there is again a one bit change. You can just notice A is constant 1 throughout, whereas B and C it is 00 here and here it is 10. There is just a one bit change. So this grouping is valid. This is an essential prime implicant. For the sake of this one and for its better grouping, this is very much mandatory. So you will have, for this grouping you will get A C bar. A C bar is fine. A C bar will be the first term. And for the sake of this one, you have no other option. You have no other option. It should be grouped along with this, with the neighboring 001. So the other grouping that we are going to perform for the sake of prime implicants is, it is going to be this one. For the sake of the 1 and 011, I am just performing this particular grouping. Once I do that, I'll end up with A bar C. So the other one is A bar C. And this one, for the sake of this one, I can perform either this grouping or else this one. We are not sure about what option is given for us, but both are equally valid. Both are equally valid. Okay, so once I perform this grouping, if I perform this column grouping, I'll have B bar C. If I perform the column grouping, I just form a pair and it is B bar C. So all the ones are grouped. So all the three we have obtained is an essential prime implicant. There is one more possibility. The other possible prime implicant is when I perform this grouping, I will get A B bar. A B bar is also an equivalent essential prime implicant, but that is not given in the solution, so you can just ignore it. The other possible grouping that you can get is equally valid. Instead of this, it can be either B bar C or else you can perform this grouping for the sake of this one, ignoring. Once you perform this grouping, you will end up with A B bar. A B bar. But among the options, we just have A bar C, B bar C and A C bar. So this is your valid answer. For the given function, the Boolean expression can be, there are two options, y is equal to A C bar plus A bar C plus B bar C. And the other option is again y is equal to A C bar plus A bar C plus A B bar. Both the Boolean expressions are equally valid and both are correct. But this Boolean expression is the one which the examiner has taken into consideration. So all the three product terms you get in this Boolean expression are the prime implicants. So it is A C bar, A bar C and B bar C. These three are the prime implicants for the given problem. Thank you.